Hello, assalamu alaikum. My dear students, how are you all? I hope all you are staying at home. You are fine, healthy, and doing the online classes properly as we are going through a very crucial time, a pandemic situation. So we have to take care of our health, but at the same time, we have to take care of our lesson also. Okay. For this, we have to learn through the online classes of the Shanaj TV, that means from the government side, and also from the school. We are trying to provide you a routine basis online classes. So you must do the classes properly, write the information notes in your classwork copy, and must follow the instructions. That means whatever the homeworks are given, you must write all the homeworks in your homework copy. Clear? So here today I will take a science class of class 8 and I will take chapter 7. So go for the class. Thank you. So we will start our class. Our class is of class 8 science and our class number is 28. And here your teacher Mrs. Shanaj Parven Asha. She's from English medium senior section. No, sorry. I'm from English medium senior section, sector 11, and I take science and ICT of class 8. Thank you. So today we will do a science class, and our class is on chapter 7. Chapter 7, the name of the chapter is the Earth and Gravity. All you know, as you have finished this chapter beginning of the year, before first evolution. Okay, so what we will do today, we will have a quick review of this chapter, and I will discuss the creative question, how to write the creative question answers according the board exam. Okay, and what are the quick reviews? We have to know all these points, because in this chapter all these points are discussed. First of all, gravitation, then Newton's law of gravitation and gravitational force, gravity and acceleration due to gravity, variation of acceleration due to gravity, mass and weight, acceleration due to gravity and weight of an object different at different places on the earth, and weightlessness. All these are actually main topics. That means you have to keep all these points in your memory, properly understand this chapter. Okay, so as I said that we have completed this chapter early in the year. In that case, in case of quick review, I want to show you some videos. That means all of these topics we will observe some videos for our better understanding. Actually, we have already understood. I don't have anything to discuss newly. First of all, what is gravitation? As we know that in the universe, what will happen? Attraction force will be any two object in the universe. Okay, so in the universe, attraction force of any two object is called gravitation. So what is gravitation? We will see from the video. Let's enjoy the video.
We thought that the gravitational force is the attractive force between any two objects with non-zero mass separated by a distance. So does the apple fall towards the earth, or does the earth move towards the apple? Or do both move towards each other? It's actually simple logic. This is the earth, and say this minuscule object is an apple. Based on what we learnt about the gravitational force, both apply an equal force to attract the other object towards itself. So if the forces are equal, which one will accelerate more? Based on the Newton's second law, we know that the force applied is the product of mass and acceleration. So the acceleration will equal force over the mass. The acceleration is inversely proportional to the mass. If the mass is more, the acceleration will be lesser. As the mass of the earth is much more than the mass of the apple, it is the apple that accelerates towards the earth and not the other way around. Hope that makes it clear. Now the question is, how do we quantify this force? To understand this, we need to understand a simple concept. And this simple concept is called the universal law of gravitation. Say there are two objects A and B separated by a distance d. The distance between the centers is considered the distance between the two objects and not this distance. Assume that the mass of object A is m1 and that of object B is m2. As object A is bigger, let's assume m1 to be bigger than m2. The universal law of gravitation says that every object in the universe attracts every object with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Let me repeat. The force is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. With this data, we can write it mathematically like this. So if the mass of any of the objects increases, the gravitational force will have more magnitude. And more the distance between the two objects, the lesser will be the gravitational force. Directly proportional to the product of the masses and inversely proportional to the square of the distance between them. This can be written as F equals G times m1 times m2 over d squared. G here is the constant of proportionality and is called the universal gravitational constant. The equation can be modified and written as G equals F times d squared over m1 times m2. The value of G was found out by Lord Henry Cavendish using a torsion balance. The universally accepted value of G is 6.673 times 10 raised to negative 11. What will be the units of G? Force is newtons. As the distance is in meters, we have meters squared. And as the mass is measured using kilograms, we multiply this with kilograms raised to negative 2. This is the value of the universal gravitational constant.
So I hope you enjoyed, and you must keep in your mind this value. Okay, though the value is not written in your book, but we have to keep. Okay, see now, one thing I have to clarify, because this point is very important. That is, if you know that force is directly proportional to the product of the masses, and in this case the size, that means when the mass will be double, that means this mass and this mass, suppose it was 10, it was 20, and it becomes double. Okay, so if the product of the masses becomes double, keeping the distance constant, that means it will not change, it will remain unchanged, then the force will be double. Force become double. Again, as we know, force is inversely proportional of the distance. So if we keep the masses constant, that means the mass will not change. But if we change the distance, that means if we double the distance, in that case what will happen? The attraction force will become 1/4. As you know, you have seen that if D increases, F decreases. Why? Because it is inversely proportional. If product of the masses increases, force also increases. If it becomes double, it becomes double. If it becomes triple, it becomes also triple. It is become fourth, it will also become fourth. That means what will happen? As it is squared, that's why if it is double, then F will become 1/4. It is triple, F will become 1/9. And if it is 4 times, F will become 1/16. So what will happen if it becomes 5th time, my dear students? Right you are. It will become 1/25 times of the original force. Now proceed for the gravity, another video.
When you drop a stone from your hand, it falls to the ground. It's an example of free fall. Whenever objects fall towards the earth under this force alone, we can say that the objects are in free fall. The stone accelerates towards the earth, and this acceleration due to the gravitational force of the earth is denoted by lowercase g. Using a few mathematical equations, we derive the value of g as this. Remember, this is only for free fall for objects very close to the Earth. Uppercase G is the universal gravitational constant. M is the mass of the Earth and R is the radius of the Earth. So for specific case of objects close to the Earth, we get the value of G as 9.8 meters per second square. But do you know what's interesting? This acceleration is not dependent on the object's mass. This M is the mass of the Earth, not the object.
Okay, we will enjoy another video. That video is on about the experiment of Galileo due to acceleration due to gravity. Galileo of due to acceleration gravity. Okay, how actually it measures. That means what will be the acceleration due to gravity of an object. I hope you will enjoy the video much.
And it does that by pumping out 30 tons of air. Okay, we dropped 2 millitorr in the last 30 minutes. But once it's complete, there's a near perfect vacuum inside. Isaac Newton would say that the ball and the feather fall because there's a force pulling them down. Gravity. But Einstein imagined the scene very differently. The happiest thought of his life was this.
So our next part is mass and weight. Again, watch another video.
Most of us think that mass and weight are pretty much the same thing. Are they? No, they're not. There's a very simple way to understand the difference. Mass is simply the amount of matter that's present in the object. Now consider two situations. One in which an object is on the Earth, and second in which the same object is on the Moon. Will the mass of the object be different in these cases? To answer this question, we ask ourselves another simple question. Will the amount of matter present in the object be different in these cases? Absolutely not. The matter in the object is not changing at all, which is why the mass will be the same in each of the cases. The mass of an object remains constant no matter where it is placed. The standard metric unit of mass is the kilogram. Another concept we'd learnt about an object's mass was that it is a measure of its inertia. Greater the mass of an object, greater will be its inertia. Inertia is nothing but the tendency of an object to resist change in its state of motion. So now we have an idea about what mass is. But what's weight then? How do we understand the weight of an object? Mass is nothing but the measure of how much matter an object has. Weight is a measure of how strongly gravity pulls on that matter. It's the measurement of the gravitational pull of an object. Let's understand this using a simple example. Say there are two places, place A and place B, and there's an object of mass m. In place A, the pull of gravity is x units, and in place B, the pull of gravity is 2x units. Clearly, the pull of gravity is stronger at place B. Now understand this well. The mass of the object will be m at both the places, but the weight of the object will be greater at place B because the pull of gravity is stronger. As the gravity is twice as bigger, the weight of the object will be twice as much at place B as compared to place A. So the weight of an object is a measurement of gravitational force acting on it. How can we understand weight using a formula? We know the Newton's second law of motion, which says that the force acting on an object is the product of its mass and acceleration. When it's acceleration due to gravity, we can replace A with a lowercase g. This force due to gravity is nothing but the weight of the object. So if we consider the weight of an object to be uppercase W, we can rewrite this equation as W equals m times g. So the weight of an object is the product of its mass and acceleration due to gravity. What will be the SI unit of weight? Can you guess? It will be the same as that of force.
Yes.
Newton. As the value of g at a particular place is constant, We can also say that the weight of the object is directly proportional to its mass. Here's the main takeaway from this video. The mass of an object remains constant everywhere, whereas its weight depends on the gravitational force at the location.
Right. And you have to keep in mind this point, okay? Now the last topic is all about weightlessness. What is weightlessness? We already know. That means the situation where any body feels zero weight. That means the body's weight becomes zero. So when or which cases we can achieve weightlessness? When during freely falling under gravity. Okay. And then inside the spacecraft or satellites, and then at the center of the earth, and when a body is lying in a freely falling lift. So you have learned in the last lesson about all these topics, and also you have learned when we go upstairs, a lift is going upward direction, that time what will happen? Lift is going downward direction, what will happen? Is it? We feel lighter when we are going down, and we feel heavier when we are going upward direction. That's all from the lesson. Now we will go for the creative question. Okay, now come for the creative question. Here our first creative question, there is a stem. Okay, stem is like Surela laid a piece of paper of mass 0.5 gram, and see here one thing, the mass is of 0.5 gram, and a stone of mass 50 gram to fall from a roof of their building at the same time. Here her brother, standing on the ground, observed that stone reached the ground earlier than the piece of paper. So this is the stem. Here you have to focus some basic points. What are the concept? What are the main point to note? Like mass of the paper, mass of the stone, and what is the concept? That they have thrown or they are falling from the same height to the ground. Is it? Now, first of all, you have to focus in the stem. You have to understand what is explained here. If you could understand the stem part properly, in that case, you can write the C and D properly. Now, what is gravity? We know what is gravity. It is knowledge base. And in case of knowledge base, you have to directly write from the book. You cannot make your own. Okay, as it is knowledge base, that means which knowledge directly you get from the book, that one you have to imply. So what is this? I'll write the definition. What is called gravity? The attraction force that works between the earth and any other material due to earth is called gravity. Next one. What is meant by acceleration due to gravity? It is obviously understanding base. Okay, so in case of understanding base, what do you mean by acceleration due to gravity? You have to write in knowledge part. Then knowledge part means there is two part. One is knowledge part and another one is understanding part. So knowledge part, you will write the definition, and that means what knowledge you get from there, and obviously details of this, like it comes from acceleration, and then how acceleration works on with gravity, and altogether it is called gravity, acceleration due to gravity, and then how it donates or indicates, okay, G, and obviously the unit also you have to write. Next one, find the weight of the stone. Here mathematical analysis, or you can tell it mathematical application. Better to tell mathematical application. So in mathematical application, what you do? Stone was of 50 gram. Stone was of 50 gram. So here it is the answer, 50 gram. Gram, we cannot keep the mass in gram. We have to use the unit, main unit. That means that is called SI unit. Okay, the SI unit of mass is kg. So we have to convert it in kg first. So to convert in kg, we have divided by 1000. You have to write the unit. In case of acceleration due to gravity, as it is not mentioned where it is, like in polar or in the moon or in the equator, nothing is mentioned. So when nothing is mentioned, we will use the standard value. Okay, and obviously write the standard value 9.8 with the unit, and then the weight of the object W equals to mg. This is the most important part of this question answer, because it is asked that do you know the formula of weight of object? Yes, I know. So you have to put it. And can you apply all this information in this formula? Yes, I can apply. So I have inputted all the information. Like this we get the answer. I hope it is clear to all of you. Now last question is, explain why the stone reached the ground earlier than the paper. It is a logical analysis. Okay. So what we will do, that is called knowledge base here also present. We will write the knowledge base part, then we will discuss the knowledge base part. As here also you have to explain a bit what is air resistance. We all know what is air resistance. The air that is in our atmosphere, that is the air, and it has a layer. Because of the layer, if any object is fall from the upper place, if it is lighter, it will reach the ground lately, and if it is heavier, then it will go first because it can overcome. So all the thing is explained here, and then at the end you will write your hypothesis. This is one critic question. I will go for another one. Question is, what is the here object M, and what is its measurement? Yes, mass is 60 kg, and gravitational force is gravitational force. Good. It is acceleration due to gravity. G is standard value 9.8 meter per second square. Now A number question, what is acceleration due to gravity? Knowledge base. Yes, earlier question we already answered this one in B category. That time we have written knowledge base part, and then we have written the description part, understanding part. So here you will write only the knowledge part. The rate at which the velocity of free falling object or body changes due to the force of gravity is called the acceleration due to gravity. Clear all of you? Next one is why the value of acceleration due to gravity is not equal to all the places of the Earth's surface. Why it is not equal? As the shape of the Earth. Okay, so we have written the knowledge base part, shape of the Earth. You can write directly due to the shape of the Earth, and then you can write this description part. Why? Because equator distances R increases. R means radius increases. Radius increases means distance increases. That's why the value changes. Okay, where R increases, that means radius is bigger. Sorry, yeah, radius is higher. There the value of G, that means acceleration due to gravity, is lower, and where radius is lower, there acceleration due to gravity or G is higher. Okay, all this explained here. Next one is find the weight of the object at polar region. Find the weight of the object at polar region. So here we will do the same, but here one thing, it is mentioned polar region, so we cannot use standard value of G anymore. The object is 60 and the value of G at polar region is 9.832. Is it? And the same as it is, so it is only the change, because you have to use here. The question is asking that do you know the value of G at the polar region? Yes, you know. You have to put this value. And then, do you know the formula? Yes, you know the formula, and apply all the information in the formula, and you will get the answer. You must write the unit of weight. It is Newton, N. Now D number question, why does the weight of an object vary from one place to place? Analyze mathematically. So here is the mathematical analysis. That means the G is different from place to place, and that's why so weight also different. How will you prove that? You have told the knowledge base part, then you have to write the information that why the where which places, what are the values of G, equator, polar, then convenient value. Convenient value means the standard value, and at the center. Then what is the formula of weight? That one. And you have to apply all these cases. Okay, so knowledge base 1, this for in this information 1, you know the formula and you can apply the formula here 1, and you are getting this variation. As you are getting this variation, with this variation you will write your hypothesis. Clear to all of you? Thank you. This way you have to write the answer. Next one, third number critic question. Question is, mass of two bodies P and Q is 10 kg and 30 kg respectively, and distance between them is 2 meters. Now, 1 number question, what is gravitation? All we know. What is gravitation? Yes. All objects in the universe attract each other. This universal attraction force, attractive force or attraction force, is called gravitation. Next one, write the difference between mass and weight. You can write, I have written 5 here, but you must write minimum to maximum 4 point. Okay, the difference you will write minimum to maximum 4 point. I have written 5, but you don't need to write 5. Maximum or minimum 4 point you must write. Then determine the weight of the object Q mentioned in the stem on moon. Mathematical applying. So we have already done to mathematical application. We have already done to mathematical application. See here, what are the changes? G, what is the formula in case of moon? 1/6 mg. You have to keep in mind 1/6 mg. And then just apply all the information. So must keep in mind this unit you have to write, the formula you have to write, and you have to write the unit. Okay? Now, D number, the distance between two bodies become twice, then what will the change of attraction force on the surface? Explain with mathematical analysis. This question is very important, very important. It is written twice. The distance becomes twice. Sometimes it changes, like the product of the masses become twice. Okay. Anyway it come, but the procedure of solving this answer is almost same. Okay, only you have to think what is the condition. In conditional place that will be changed, otherwise not. So go for the answer. So here how we will solve the answer? First of all, what is the condition that I have written? Okay, fine. What is the condition? What we get actually, what we know actually, the knowledge pass. If the distance between two objects is increased twice, the attraction force will decrease to 1/4. The attraction force will decrease to 1/4. So our answer must be 1/4. Okay. So following the Newton's law, we will apply M1 equals M1P. We will think as M1Q. We will think as M2, and then the distance D is 2 meters. We know the formula of gravitational force F. So what is the original force? That means by this putting this value, what are the original force we get? That one we have to find out. One thing to note, you must not write the value of G. Maybe you know the value, but you no need to write the value of G, because here we no need the value of G. We want to avoid ambiguity. No need to write the value of G. So what is the second part? So what is told in the question, that the distance of two bodies become twice. Distance become twice. So we will make the distance twice. And then as the distance changes, so we will get a new force, new gravitational force. So what will be the new gravitational force? In the place of d square, we will write the value 4. The changed distance. Okay, applying this one, we will get the value. Now, so what will the attraction force? There will be a change. How we will find out, determine the change? we will divide the last change by first one, original force. Changed force by original force. In these cases, we can find out by cutting all these 1/4 times of the original force we will get. Okay, at 2 times of original force it will decrease. Okay, so here the gravitational force of attraction between two bodies change with the change of distance, and if the distance make twice, it will change the attraction force 1/4 times of the original force. I hope all is clear to all of you. Up to this, clear to all of you. So this is all about the creative question, and these are all the patterns. Among these 3 pattern, you will get almost all the answers. That means most of the question from this chapter are coming like this. So thank you all, my dear students. Stay home, stay safe, and take care of your health. Take care of the health of your parents, grandparents, and your little brothers, sisters. Okay, you can change the world. You have to keep in mind, you are the leaders, you are the blooming leaders of the world. So take care of you. Thank you.